Tutorial for Chapter 4, 4.1 Work. So the learning outcomes is the first one to state the physical meaning of dot product for W equals to vector force dot with vector displacement. Okay, so the formula is F as cos theta, because for dot product we use cos, for cross product we use sine. Okay, and then B, define and apply work done by a constant force. Okay, next, determine work done from a force displacement graph. Okay, so this is F as graph, or also sometimes written as Fx graph. Okay, so let's first discuss the first learning outcomes, in which to state the physical meaning of work done. Okay, so work done is defined as the product of the component of the force. Not the force, but the component. Which component? Component that is parallel to the displacement. Okay, component that is parallel to displacement times with the displacement. Okay, so consider we have object A. The force acting on the object is at an angle of theta. Okay, so the object is moving, making a displacement to the right. Okay, and this vector F has two components. Okay, so here we have Fx and then Fy. So between the two, Fx and Fy, which one is parallel? Which one is parallel to the S? Yes, Fx. So that is the definition, the physical meaning of the scalar product for work done. The product hasil darab component of force, okay, component of force yang parallel with displacement, okay, times with the displacement. Okay, so maybe I can write it this way. Component of the force times the displacement, in which Fx is equals to F cos theta dot S. So this one is basically the same as the formula given. Okay, so it's very important for you to understand the concept, the physical meaning of the dot product of work, because this kind of question probably gonna come out in the UPS. Okay, so try to search for the keyword parallel. Okay, kalau dia tulis perpendicular, salah lah. Okay, because dot product dia mesti parallel. Okay, for calculation, work done by a constant force, we just directly use the formula, this one. Okay, meaning that the force is not changing from the beginning until the end of the process. Okay, but work can have positive or negative value. So we look at when does work done is positive. Okay, this one is when the angle is less than 90 degree. So anything when you press cos 70, cos 50, cos 60, you will always get positive value. So that's why your work done is positive. Okay, so and then if you notice, direction of the F and the S is in the same direction. Fx is going to the right, S also going to the right. So this is what we call as positive work done. The force applied helping the object to move in the direction of the displacement. Okay, work done is 0 when the angle is 90 degree. Cos 90 always give you 0. Okay, so the force applied on the system or the object is not helping, it's not even helping the object moving in this direction. Okay, so the work done is 0 by the force. The force is not helping the object moving to the right. Next, work done is negative when the angle is between 90 degree or less than 180 or equal to 180. Okay, so cos 180 you get negative value, cos 130 you get negative value, even cos 180 you will get negative 1. Okay, so here we can see the direction of the displacement is the opposite of the force applied. Okay, so the force applied on the system in this case is opposing the displacement, so it is doing the negative work done. Okay, so maybe you can think of it this way, the positive work done adalah work done yang baik, negative work done adalah work done yang jahat. Okay, then work done by varying force. So this one, the force is changing as the time goes on. So here we have axis F, y-axis force, and x-axis is the displacement. So the area under the graph will give you the work done. Okay, but then the area above the x-axis is positive work done, below is negative work done. So in your calculation, you have to include the negative. Okay, so when we add the two value, we will get net work done bersih. Okay, ada work done yang bantu ke kanan, tapi ada work done yang melawan. So bersih yang betul-betul dikenakan pada objek adalah 7 sahaja. Okay, next, work done by a spring. So kalau work done by a spring, the formula is basically the elastic potential energy in the string. Okay, so formula dia ada half kx squared. So this one is from Hooke's law. Okay, so US equals to half fx, and then f is equals to kx, so half kx squared. Okay, so kalau soalan kata calculate the work done by a spring, use this formula, half kx squared.